And I will put you on to Andrew now to speak you through his presentation and talk more about the firm and all the projects that they'd be up to.
Thanks very much. You know what, just as you were saying that, I suddenly thought, I haven't put a single picture of Bushy in the whole presentation. So if you want to see that, you have to go on our website.
There's videos and stuff on your website, I guess.
And on YouTube as well. It's all made of mud. Anyway, thank you very much for the introduction. So this is us. We're Waugh Thistleton architects, and we're in East London, and we live and breathe and research and draw and talk and lecture and build and design in timber, and a little bit in rammed earth, but mostly in timber. And the reason we do that is primarily around climate change. And I'll talk more about that, but our kind of ideas really as a practice about how we recognize our impact on the environment, and that we think about, you know, the kind of issues around climate change and construction, have really kind of boiled down to sort of, you know, to a simplicity of architecture, to thinking about the materials that we use, where those materials come from, what the carbon impact of those materials is, and less really about the kind of operational use. So lots of the work that's been done around reducing construction impact and buildings impact on the environment has been done about the operational carbon. So the carbon that's used in the heating, the lighting, and the air conditioning of those buildings. And you get a building like this one here, which is Norman Foster's Bloomberg building, about £1 billion worth of building in the city of London. And it's got all the kind of LEED and the BREEAM and all the kind of, you know, the sort of superlatives that one can imagine around those. But actually, you know, and the mechanical engineer on the job told me they'd spent £100 million improving the building over and above building regulations in terms of those kind of mechanical systems. You know, but the engineer said to me, you know, of course, if they put a poster up outside the building in the summer that said, take your jacket off, and another poster up in the winter that said, put a jumper on, they could have saved £100 million off the project. And they could have saved an immense amount of stuff, kit and systems, etc., going into this building. Now, my suspicion is that, you know, as a kind of Western capitalist society, that actually faced with a problem, we look at how we can invent our way out of the situation, how we can layer more stuff onto what we already have in order to dig ourselves out of the hole we're in. But actually, it's the stuff and the amount of stuff that put us in that hole to begin with. So what we're looking at, what we're investigating as a practice, are not only buildings that are made of timber, built of replenishable materials, but buildings that kind of begin to recognize a simpler architecture, begin to celebrate things like space and light and material, and are not about multi-layered systems on top of each other. So, you know, in Europe, across Europe, we measure carbon by the operational carbon. So the heating, the lighting, the air conditioning, and that's the light blue line here. And the yellow line are the building materials that go into that building, the construction materials and the construction process. And when you start, obviously 100% of the building's carbon footprint are those building materials and the processes. But over the 50 years that the building is measured in, a little bit more than half of the operational carbon. But we don't have 50 years. In fact, we've probably got less than 20 years. So if you look at a building over that time, 2/3 of it are down to the building materials and the building process. And we don't currently capture that or measure that at all in Europe. So our kind of mission as a practice is really has been for the last 10 years or so, is to push that message of embodied carbon or upfront carbon from construction, which represents about 25% of the entire globe's kind of greenhouse gas emissions are about construction. So this really is the job of architects to start to talk about this. And we don't bother with BREEAM or with LEED or with any checklist. We're not designing to checklists. What we want to do is design to aspirations. So we use the UN sustainability goals, we check our work against those goals, and we start to think of our work not only in terms of, mitigating or reducing its impact, but how it can be regenerative, how it can actually help society in different ways. And we're active as an office. So we protest and we march, and we haven't glued ourselves to anything yet, but it could still happen. So and we talk a lot and we meet a lot. So we're one of the founding signatories of the UK Architects Declare movement, of which there are now 6,000, just over 6,000 practices across 26 countries have joined. So it's a really exciting kind of time where I'm really beginning to feel that things are changing. You know, that there's a sense of kind of a sense of, you know, that we can change, that we really do have the kind of the power and the will and the is really beginning to transform, which is very exciting. So this journey for us started in terms of cross-laminated timber. We built our first one in 2003. And in 2008, we built this 9-story building in East London, about 5 minutes from where I'm sitting right now. And it's a 9-story tower, 8 stories of timber, and that's all the internal walls, external walls, the staircase, the lift shaft, everything made of timber. And 4 people put that building up in 4 days, built the entire structure using cordless screwdrivers. So no cement mixers, no grinders, no jackhammers, none of the noise and filth and dust and hostile working environment that you get on a typical building site. You can see here, just really simple, little kind of like 75 mil angle brackets and 120 mil screws, little plastic tags in the ceiling where all the pipe work and all the electrics go. And so that building was completed in far less waste because it was all prefabricated, very quiet because there's no cement mixers and jackhammers, very few deliveries, and 80% reduction in construction traffic to the site, and lightweight. So it weighs about a fifth of what a concrete building would have weighed. So the implications on foundations, but also just kind of transporting stuff through central London, vastly reduced. And we sat down after we'd finished that building as a practice and thought about what we were going to do and how we were going to think and talk about what we had done, you know, because you kind of get the photographers out and you start thinking about publishing it. And then we started to get a lot of questions from other architects, from clients, about how we'd solved certain details. And we came to a decision that as a practice, we would be completely open source about what we did, that we would share information, that we would talk to other people about it. And so that ended up with us writing a book, which you can still get on Amazon. And in 2009, A Process Revealed, which was all about the building of Murray Grove. And since then, we've gone on to build lots more cross-laminated timber buildings. We've finished about 25 now, and we have about 15 in the office at the moment. And this is my house where I live, and I live in the middle bit here, just in these 2 floors. Can you see my mouse, Glenn? Can you see the mouse there? Yeah. So I live in the middle bit here. My friend Jason and Laurie live there, and Dan and Nick live here. And the 3 of us bought this piece of land, and we sold our flats and sold our cars and sold some of our children. And we bought this land, and then we got planning consent for this. And so then we had to, in order to be able to afford to build it, we then had to sell off the commercial floors, this lower ground, and this central floor here. And the photographer that we sold the middle floor to wanted to have a studio space that was 26 meters long, 6.5 meters high, and 9 meters wide, in order to get the kind of clear shots that he wanted for the kind of work that he does. So in complete kind of like opposition to the sort of honeycomb, look at this, like, see this kind of honeycomb structure that we have on Murray Grove, this building here uses a lot less timber. And because we had to have this space with no columns and no beams, we had to work out how to get the flats on top of that. And so what we did is we used the party walls here as deep beams. So those party walls, they hold the floor slabs, and the beams, because it's cross-laminated, it actually acts as a bit, the wall acts as a beam, able to carry the load all the way along it. So what we were able to do is to use those party walls as deep beams, and each one of those deep beams is supported by the front and the rear elevation, which acts as these giant trusses across the building. So you have a really lightweight, kind of tight building. So what we're beginning to do with this building is to kind of understand that when you change a building material, you change the process of construction, which is what we really began to understand on Murray Grove, but you also begin to change the opportunities for architecture, and you begin to be able to explore what may and what should become a new kind of architecture, because it's a new material. And then you also realize that all your visual kind of lexicon of buildings, like all the buildings that you've looked at as an architect since you're a student, are all concrete buildings. And that these buildings are what form your kind of collage of ideas about new types of art, about your new projects. And to reinvent this, to begin to really rethink that is the real challenge. So this is where I live now. So just in there, it's my sitting room up there. And so that's what, 8 years, wow. And this is a building that you mentioned earlier, which is Dalson Works. And this is an important project for us because it's big. And, you know, challenging the idea that concrete and steel are the only way to build high density urban housing is really important. Demonstrating that timber is a viable alternative to those carbon intensive materials is really what we're out to do. So the idea that we can build at scale in timber, that we can actually make a difference in terms of greenhouse gas carbon emissions is really important. So if we'd built this building in concrete, would have weighed over 10,000 tons in concrete, but building it in timber is less than 2,000 tons. So less than 2,000 tons, about 2,500, 2,400 trees. And there are 800 people living and working in the building. So that's less than 3 trees per person in the building. And it was also incredibly quick. So you can see here on the left, the structure going up. So 10 stories, 17,000 square meters, 4,000 square meters, 121 apartments, and 4,000 square meters of commercial. And as I said, quick. So by the time the train's gone past, the building's finished. And we wrote more about that. So we kind of so the other thing that we did, we worked with the US Department of Agriculture on a research project looking at which buildings have been, looking at all the buildings that have been built in CLT in the UK. So we researched, there are about 500 completed now. At the time, probably about 350, 400 completed. We spoke to a lot of the clients, to the architects, the engineers. We kind of boiled that down to 100 projects. And this is available free online. So this is at thinkwood.com. And this details all those buildings. It gives some insight into why clients, why architects and engineers made certain choices along the way. And so our projects have grown over the years now in scale. As I said, we've completed about 25 buildings, and those started in Hackney, where I live and work, and then kind of in London, and then in the UK. And now we're working further and further afield. This project is in Bergen in Norway, and it's 2,000 homes, and the primary school and a health center and some shops and some offices. And it's on a lake in Bergen in the middle of the town. This is the old town to the left, the new town to the right. And the idea is to provide a linking bridge between the old town and the new town, to build this new housing from locally sourced timber. And for the foundations, we're using rubble that's taken from the construction of the new public transit system. And one of the ideas that we have is with the rubble in the foundations, that we're going to use that to build a series of oyster beds below the buildings in the foundations, and that those oysters will be able to clean and filter the lake such that actually by the end of it, people will be able to use the lake again, although it'll be quite cold. And those are buildings for families, for young people, for elderly. So a real kind of a real community. And there's the kind of the glamour shot of the new bridge and the quays for boats, etc. And as we've done that, you know, as we've been working on this kind of on this sort of architectural kind of journey, learning and thinking and understanding about this new material, we've also begun to think a lot about the construction process. Now, people are building buildings now almost exactly the same way that they were building them 100 years ago. In fact, we're less productive now in construction than we were 70 years ago. So we make buildings more slowly and more expensively than we did 70 years ago. Now, this is kind of crazy. And you can see other types of manufacturing, car manufacturing, the advances that have been made in car manufacturing in 150 years have been incredible. And yet really in construction, not much has changed. So we have begun to think and to look more about car manufacture, looking more about actually how you build a chassis. So this is a Mitsubishi GS chassis. This chassis here builds all these cars, so all these different cars, 14 models across 6 different brands. They're all built from the same chassis. So this notion of a kind of chassis, of actually manufacturing, pre-manufacturing homes and thinking about what the opportunities are there in doing that, is something that we become increasingly interested in. So each one of these cars has more than 500,000 choice combinations involved within them. So of these 14 models, you have over 7 million different car combinations that are available just from one chassis. And in fact, when we spoke to Nissan, Nissan told us that they make the same car every 6 months. This is an Opel Ampera. Now, an Opel Ampera is available on the road for about £20,000. It has a 6-year warranty. Anything goes wrong with it for the first 6 years, you take it back, they sort it out. It's an amazing piece of engineering. It's designed through its supply chain. So each one of the suppliers to this car are designing and perfecting the component. The designer of the car is going to those individual suppliers and talking to those suppliers about what the opportunities are for making a better car. And so as we begin to investigate more in terms of how we can make modular housing, we're very wedded to the notion of working with supply chain, understanding how we can improve the choices that are available, how we can improve the quality, the working environment for people. So construction sites are typically really hostile working environments that not many people want to kind of be involved in. So actually kind of making better working conditions for people, I think will give us better architecture, a better quality of building, and more choice ultimately for people buying those houses or renting those houses. So this is our first, a couple of years ago now, our first CLT box, and a box, so this is half of a 2-bed apartment. And one very similar to this was lifted on earlier this year onto a building that we're building in East London. And this is low-cost housing in Tower Hamlets in East London. And again here, the tenants are able to make choices about the type of bathroom, the color of their living room, the type of carpet that will be in there. All these choices will be able to be pre-made so that they can, those choices are made as the boxes are going through the factory. And then those choices just appear on the BIM model and are very simple for the people in the factory to instigate. So really, I think a new way of thinking about building homes beyond that kind of white box. And that sort of, I guess, kind of way of thinking about construction led us to be involved in a project for Vitsœ, which we completed a couple of years ago now. Vitsœ is a shelving system which was designed by Dieter Rams in 1960. And it's the most beautiful, kind of precise, modernist kind of shelving system. We've got it all over the office, as you can probably see behind you. But Vitsœ came to us and said they wanted a building that was as accurate and precise and as adaptable as the shelving system which they manufacture. So with this shelving system, you can kind of take out these elements and replace them with different elements. You can move it to a different house, you can extend it, you can contract it, and you can use it for lots of different things. So the idea was that we would give them a building that actually performed to the same level, which is incredibly difficult. We were having a conversation earlier about product design. The manufacturer, the creation of product design is so much more sophisticated than we're used to in construction. So actually working those ideas through, designing it with Vitsœ, with Martin Francis, from Vitsœ with the engineers, was an incredibly rewarding process. And you can see this building here, which emerged, is based on a kind of double portal frame, like a sort of church aisle and nave. And this frame is made from LVL, so from a hardwood laminated veneer lumber. And the difference is, I mean, I think we probably all know about CLT being planks of timber, which are cross-laminated, so glued perpendicular to the layer below. And how an LVL works is it's on a veneer. So rather than cutting planks out of a tree, you're peeling the tree to get a veneer. So you use about 90% of the tree when you do that. So it's really efficient. And if you use a hardwood and you get those veneers and you layer them up like plywood and then chop them into beams, it's incredibly strong. So as strong in section as steel is. So we have these kind of like these series of frames that are then clad in a CLT and have these kind of roof lights here. You can see the glazing here. And so you can see the CLT, the softwood CLT skin on the outside of the building. Here, the roof cladding going on. And inside the building, this very slim frame. So these are the hardwood beech columns and beams, and then the softwood CLT between them. And this north light here means that the entire building is daylit, 100% daylit through the daylight hours. And even this kind of like very kind of pared back internal finish to the building promotes that notion of adaptability. So now it's a factory and a library and a restaurant and a ballet school. And that idea around prefabrication was also something that when the V&A approached us a couple of years ago to talk to them about doing a sculpture in the courtyard of the V&A for the London Design Festival, we were very keen on doing something which was along the lines of what we are currently thinking of. So they were kind of, you know, we were suggested by the American Hardwood Corporation to do the job. And I think there was a bit of reticence because the architects that had been involved in those sorts of projects before us had done very sort of sculptural kind of elements. And we were like, yeah, what we want to do is we'd love to do that. And we want to talk about low cost social housing built from modular units. And we want to do an exhibition of that. And they were like, nah, it's not really the kind of thing, you know, so we put together this kind of modular CLT program using a hardwood CLT. So we got delivered from the States this type of timber called tulip wood, which is like the kind of crappiest low-grade hardwood that there is in the States. So it kind of grows like a weed across America, very fast growing, very multicolored. So it's not really used in furniture or anything like that. And it's usually pulped up and made into cardboard or made into pallets for carrying things. And so we had delivered a couple of loads of this. And in CSIC, which is the Construction Innovation Centre in Scotland, just near Stirling, we made our own CLT from this hardwood. This is Neil and Duncan here making CLT in Scotland. And from that CLT, we constructed these little kind of hardwood CLT boxes. And you can see really thin. So that is about 75 mil on the floor there. And each one of these boxes is constructed to carry 30 people. And then we built these boxes up into this kind of form in the V&A, which was really fun. And then after that, we took it to the Milan Design Fair, and then we took it to Madrid, and then it was supposed to go to Venice, but then we had COVID, so it didn't. And so now it's in a shed somewhere, but it will be used again. And we had, if you can see, we kind of sneakily kind of put this little messages on the boxes here about how much carbon was stored and how, and how this is the future of social housing and all the things that the V&A weren't really keen on us talking about. And so this year we've completed this building, which is Orsman Road, which is a big office building, again in Shoreditch. And we've done that combining CLT and steel. So we made sure that all the steel was bolted, not welded. So it's completely adaptable and interchangeable. So in fact, here you can see we, after the building was complete, the occupier that took the building wanted another kind of public open staircase in the building. So we cut the floor slab out of the building and we made a new stair using the floor slab. And that only took about 10 days, so it's really effective. So that's that finish there. You can see the stair in the background there. So the steel takes the gravitational load and the timber takes all the shear load. So we have a timber core and a timber floor, and that takes all the kind of wind load like that. And then the steel takes the load of the timber, which is very light, and the people on it. So you can see very few columns in the building, incredibly kind of pared down steel structure. And that's that building from the back. That's actually a render, I think. Yeah. And we're working on another one, actually very close to that one, called the black and white building for the office group, which will be made entirely from timber. So that's using the same principles that we used on Vitsœ. So that LVL frame, CLT floor slabs, and then completely clear glazing. So we're very keen on kind of on an understanding of the health and well-being within the spaces that we think about, making sure that those spaces feel, it's kind of close to nature as one can in that kind of environment. So not having kind of tinted glass, but making sure that we give proper solar shading to the glass, so we don't need massive air conditioning systems, but making sure also that when you're in the building, you get a real understanding of what the outside is like, of what the outside weather conditions are like. So that, again, a really simple structure. So you can see here the LVL column, LVL beam, and you can see those metal connections there. We bury those in the timber in order to fireproof the connections. And that's the kind of close-up render there. That's life in Shoreditch. And we're building another building in the States, which is made of strand board, so sterling board, and layers of strand board. We're really interested in strand board because strand board is made from predominantly made from recycled timber. So one of their biggest suppliers of raw material is the Salvation Army. So when you go to one of these factories, these kind of trucks are arriving with loads of old furniture piled up high. The furniture goes into a big silo, gets kind of ground down into wood shavings, and then lots of little hinges and screws kind of fall out at the bottom. And then you get this amazing kind of strand board going through the factory. And so the idea is that we make them a new office building entirely from strand board. So putting those building box beams and box columns together using strand board for the factory. And that's an office building which will appear in each one of their factories in 16 different countries globally. And then I thought I'd just kind of put this in because this is obviously what's confronting us all at the moment. And I think that I kind of touched on it a couple of times before, but I think it's, when you kind of find yourself in a situation that feels kind of both perturbing and also you think, well, what will the effect of what we're going through at the moment have on architecture? Thinking back 100 years ago, after the First World War, when we had the Spanish flu, and the Spanish flu 1918 to 1921, it infected a third of the world's population and it killed 1 in 10. Now, this was the most kind of awful disease, terrible illness, which we still have, circulating, annually, is this flu, which we've become increasingly used to. But when it first appears, it really decimated people, especially after the First World War, but actually massively more than the First World War had done. And yet what happened following that was the societal behavior, societal attitudes towards cleanliness, towards science. We had vaccinations, we had germs, we had antibiotics. We had this kind of newfound faith in science, a newfound desire for clean surfaces, for tubular steel, for things that didn't accumulate dust. So globally, there was a global movement towards a new kind of architecture that recognized the pandemic that had gone before it. So I think it's going to be really interesting to see which of the ideas that are lying around at the moment will be picked up by society and seen as being the imperative for kind of moving forward in a post-pandemic world. Because I don't think that things are going to be as they were a year ago ever again. You know, we will move forward. We will not want to be, in all likelihood, you know, in a lot of the kind of spaces that we've lived and worked in before. They just won't be, you know, spaces that people want to be in. We will, I think, be creating spaces with far more natural materials, with a far greater kind of connection to the outside world, indoor, outdoor living and working. So that health and well-being of those spaces, I think, will become the next normal, a new typology for architecture. And we know from work that we've done before and from work that the Australians and the Americans have done, that actually living and working in buildings with natural surroundings doesn't only make us happier, it helps us to concentrate. It gives us, you know, we have fewer sick days. It reduces your blood pressure and your heart rate. It's just good for you to be around natural materials. I mean, as soon as you say that to yourself, you think, yeah, absolutely, that chimes. I totally understand that. So part of that work is involved as well in our Build in Wood, which is a big research project that we're running in the office, kind of competition that we won with the European Union, and we're working with a dozen or so other partners on that for the next 3 years. And that's looking at new types of construction system where we can employ timber to build a typology, to build an architecture that can transfer or be adaptable from office to residential uses. So that's kind of like, and that will form a kind of parametric design for manufacture and assembly, so that we'll be able to kind of work within parameters of those construction, of the kind of like typical workspace, typical kind of living space. And this is really embarrassing. That's the cleaner. I'm just going to have to let the cleaner in. I'm so sorry. Will you give me 1 second? Is this being recorded for a comedy moment? Hang on a sec.
You just pause it.
You start in a moment. This is really exciting. So the idea that, and what particularly kind of I think is so kind of wonderful about this is that you know, the timber that we work with, the cross-laminated timber, is a really simple, rudimentary material. You know, these are secondary grade planks of timber that come from the outside of the tree. This is the stuff that actually isn't, you know, it's not a sophisticated product. And yet the systems that we manufacture this from are incredibly sophisticated. Would you mind starting downstairs? Is that okay? Thank you. And so the systems that we work from are, you know, the kind of computer, the IT systems we work, incredibly sophisticated and working with this really rudimentary material. And I find that really exciting. So this is just some of the models that we can get, but some of the initial models that we're getting from that DFMA system, which we're able to kind of, you know, just demonstrate the kind of the variety, the variation that, that's feasible with that. And we know that we must be having some success with this work and these arguments, because these are adverts that have been put out by the General Cement and Concrete Association, the Global Concrete and Cement Association. So they're after us. You know, this is like tobacco in the 90s, right? This is kind of, so they're lobbying government hard all over Europe, in the UK as well, trying to defend the position of concrete at the moment and steel. And part of working against that, those lobbying situations, are having to deal with changing building regulations. And so post-Grenfell, we have had changes in fire regulations in the UK. And so what we're working on now are research projects to demonstrate how safe timber is. So to build a new model building, which is one that does comply to building regulations, can be insured, can have a mortgage against it. So just really taking things right back to basics to give people an opportunity to say, well, actually, it can be done. You can do it. Here's a collaborative kind of open source model project that can actually allow people to build urban housing, high density urban housing safely, and also knowing that they can get insurance, etc. for that. So very lastly, I'll tell you what I'm excited about at the moment. And I'm excited about the opportunity to take the buildings that we already have and to think about how we can retain those buildings, how we can adapt those buildings. So this is a picture of Manhattan. The average office building in Manhattan is over 80 years old and fast becoming increasingly redundant. So how can we take these buildings? And you know what? Not only is it incredibly carbon intensive to take these buildings down and to rebuild them, but also it takes years. So one of these ones, I think it's kind of this one here, is being demolished at the moment, taken down. You can imagine, taken out truck by truck through the Holland Tunnel out to New Jersey, dumped somewhere in New Jersey, and then all the way back in, all the concrete, all the steel coming back through the Holland Tunnel being built up. That's about 8 years worth of building. So really not financially viable to do that. So you're going to be left with this city of these redundant kind of towers. So what we're looking at is a series of projects at the moment where we're taking those existing concrete structures and thinking about how we can extend them, how we can reclad them, and how we can adapt them, but using the existing concrete frame and the existing foundation. So we're not kind of impacting, and we're keeping that existing kind of carbon safe and stored. And this is the number of tree seeds that grew the trees that built our first tool project, Murray Grove. Thank you.
That's lovely, Andrew. That was really interesting talk just there. Just if you'd stop sharing your screen and we can ask some questions.
Great, I'll do that. Oh, that's the Waugh Thistleton Foundation. That's something we're starting at the moment. This is just that's my holding screen. Hang on a second. Let me just stop share. There we go.
Yeah. Yeah, that's great. Thank you. So we had one question come in just to start with. When you mentioned equating to, if you're coming in now, to 3 trees per person, did you replant those trees to make the building more sustainable?
Yes. So we only ever use trees that are either FSC or PEFC certified, and every time that you chop down one of those trees, you have to replant between 3 and 5 new trees in its place. So in fact, all the forests in Europe which contribute towards CLT manufacture, each one of those forests is still growing year on year. So they're all increasing in size.
Yeah. Thanks for the talk, message from Hannah. Thanks for the talk. I found this really interesting. I had just typed this out question before your last slide, but maybe you can expand more anyway. What are your thoughts? Where do you see timber construction heading? All the options on timber in this construction is sometimes thought of negatively due to tragedies such as Grenfell Tower.
Yeah, so I'm quite kind of evangelical about this in the sense that I think that the majority of buildings, by the end of this decade, I think the majority of buildings will be built from timber. I think that we will be seeing carbon taxes very soon after the next climate conference. We'll be seeing climate taxes across Europe. We're already seeing new government legislation coming in Europe about upfront carbon, so embodied carbon, about how we can reduce that. I think as we get better at generating renewable forms of energy, that we will we will realize that actually the carbon savings that we need to make will predominantly be about our relationship with the planet. And it'll, we need to stop scraping stuff off the surface of the planet and using it as though it was endless. So we need to be thinking about replenishable materials, about things that we can grow, etc. Now, in terms of Grenfell, the awful tragedy at Grenfell, when the Hackett report came out, the Hackett report said, you need to change the systems of construction. You don't need to change the building regulations, they're fine. You need to change the system of construction. And what happened after the Hackett report was that we didn't change the systems of construction, we just changed the building regulations. And exempted from the change in those building regulations, as a for instance, were PVC windows. And PVC windows were what burnt and melted and fell out and allowed the fire to spread in the first place. But we make PVC windows in the UK, and the PVC windows lobby is quite strong. So this is a fairly, awful, cynical kind of result of a fire in a concrete building. So that's my view about that.
Yeah, definitely. What about the additives to CLT, the OSB and LVL, such as glues and fire retardant coatings? What is the eco footprint / chemicals effect? And did these?
Yeah, good question. Yes, no, they don't. And the thing about CLT is, as I was saying before, CLT is really rudimentary. So it's less than 1% of the volume of CLT is glue. And there's nothing else. There's just the glue and the timber. And the glue itself is a polyurethane glue. So it's formaldehyde free, it's cyanide free. So none of the kind of nasty off-gassing stuff that you get from formaldehyde based adhesive. So it's a lot more inert, but it's still a plastic, and it's still eventually something that, that one would like to kind of find a different way of doing. But for now, in my view, it's, such a small quantity is used, and what it allows you to do is so much better than the alternative that actually it's not bad enough to stop us doing it. For LVL and for Sterling board, there are more glues and more resins in those products. We don't use those generally, apart from that factory that I showed you. We don't generally use those as much. And a lot of the companies are changing those glues at the moment. And there's a lot of research around that. A lot of regulatory things are changing. So it's a small problem. Certainly a small problem in comparison to the awful problems created through concrete and steel manufacture, but it's still something that absolutely needs to be identified and discussed.
That's an interesting point there. A few questions about a building that you didn't mention in this talk, the Bushway Cemetery. A few people asking about rammed earth. In what strategies might you recommend to seeing this material being more widely accepted and used, especially in the UK, and also people just wanting to maybe just expand a bit on that?
Yeah, sure. It was an amazing project to work on. It was a 10-year project. It's kind of like it felt at the time it was sort of like it was like a kind of student project. It's like something you get set. It's a kind of like, a cemetery for the kind of like, for the Orthodox Jewish community of North London feels more like a student project than it does, and it literally was one of those phone calls where you take the phone call and somebody on the other line said, "Excuse me, I was wondering if you'd be interested in," and it literally was out of the blue. So it was an amazing project to be involved in, a really fabulous community to work with. And the notion of using rammed earth really came to me because not only because of the renewable aspects of the material, but also because the buildings are designed to only be there for about 70 years.
Mm-hmm.
And after that, where they are will be made into a cemetery, and the Jewish community will start to bury their dead elsewhere. So the building had to be kind of able to be ground back down into the soil from where it came from. So that was a really important aspect of it. The other thing is that when you bury somebody within the Jewish faith, you bury them in the earth, and the congregation around them put the soil on top of the coffin. And you have I know because I buried a close friend of mine, you get the shovel and you put the soil on, and when you walk away from the grave, you have the soil of the cemetery on your clothes. And to go into a building which is made of that soil just seemed to me incredibly appropriate. But I think that material, is something that we can use and we will use increasingly. We've just got another 2 projects at the moment that we're looking at in rammed earth. And I think, particularly for one-off buildings, for kind of civic public buildings, it's a material that could be incredibly relevant. For high density urban housing, I don't see it as a solution, but I'm happy to be proved wrong.
That was interesting because you mentioned earlier in regards to one of your buildings how the metal wasn't welded. Is that something that you think about, kind of the circular economy of the building and its use after?
Yeah, all the time. I mean, I've always found it really depressing when people sort of turn around and say, the life expectancy of the building will be, 25 years or 50 years or something like that. You think, well, that's awful waste of time and resource, and kind of like, but we know that, the Georgian house, that kind of contained stone and timber structure, is so beautifully adaptable that they can be used for shops and houses and hotels and offices. And that kind of adaptability has given them longevity. And so for me, the idea that you think about a building in terms of its longevity, in terms of its adaptability, is a responsible kind of way of thinking about a kind of low carbon architecture. And I know that working with some of the concrete buildings that we're working with at the moment, it's a nightmare to do anything with it at all. Its quality is its strength and its kind of, and its kind of, capacity. But actually that means that in terms of adaptability, it's really difficult to work with.
Yeah, kind of following on for your point there about concrete, and that's another question. Whether there's any place for concrete as a viable material in this new CLT world.
Yeah, there is definitely. We will need concrete. We need to work out how to make concrete at a reduced impact, not only in terms of carbon, but also in terms of kind of, where we get the lime from, and and where we kind of where we get the cement from. But yeah, for sure, there's definitely going to be a civil engineering, foundations, floor slab, ground floor slab, that kind of thing, for sure. So there will be, we'll all be working in concrete, I'm sure, but just have to vastly reduce it, make it a very kind of like, it's like having a cigarette at Christmas.
Interesting analogy there.
Maybe I'm just looking forward to Christmas.
Something like that, maybe. Another question. Thank you for your energy, first of all. What's the positive view that we don't hear so often, especially in our old-fashioned? Second, are there negative aspects of timber that at a certain point made you doubt your perspective? What are the biggest limits, and what are those you might improve in the future?
That's such a good question. I went into practice straight after college, and which is not what I would recommend doing. But I went in, so we started, kind of doing kind of like bars and cafes and stuff like that, and kind of kitchen extensions. And it's just kind of like, and I've been doing it now for 23 years. And, it's just kind of like, so that kind of experience in building is something that I've gained from my own practice rather than have learned from other people. And so the idea of doing it differently wasn't an idea of it being different, but just learning how to do something from scratch, if you see what I mean. So the process of understanding how timber buildings go together has been part of my process of learning about architecture and learning how to build. So in terms of, it's my career now. So is there something I regret about that? I'm sure there are lots of little things I regret, but in the main, I'm having a great time and I'm really excited and I'm really optimistic. I think it's a fabulous time to be an architect because it's a really, really important time to be an architect. You can make a real difference now. It's that kind of, we were kind of joking about it in the office the other day. It's like kind of like, when they call for is there a doctor on the bus or something, it's that kind of moment, where society is calling out for the architect, kind of like, and I think we can change things. We can work hard in the construction industry and make a difference.
Yeah, definitely. There's a lot more of a push now, especially in our education, to try and have sustainability at the core of what we're designing. And from what you're saying today, sustainability is the core.
Think about those poor architects from 5 years ago who are studying. What did they have to study? When sustainability wasn't being taught at college, what some really kind of random sort of shape making, kind of like how strange, what kind of bubble can you make your building out of, kind of idea. I love your gallery, don't get me wrong, but the kind of like, it's just like, really, was that the sum total of kind of, of a culture's, the way in which a culture represents itself is through its architecture, and that was like some kind of like pointless little robot in the corner, just kind of banging against the wall, going nowhere culturally, having no kind of like, increasingly random shapes. Is that really a cultural kind of, zenith? I don't think so. So I think that actually now is a real opportunity to do something special in architecture.
Yeah, definitely agree with that. We've got another question from Jason. I've been fortunate to work with a number of design consultants. I've worked in some of the projects you've presented tonight. I'm truly converted. What can we do to support and accelerate the adoption of mass timber construction? Also, that was a fantastic presentation. Thank you, Andrew, for sharing and facilitating an open source approach to improving future society/environment.
Thank you. What was the question? I'm all embarrassed now.
Yeah, noted praise. I've been fortunate to work on a number of design consultants that have worked on some of the projects you've presented tonight. I'm truly converted. What can we do to support and celebrate the adoption of mass timber construction?
I think, really learn how to do it. Talk to people about it. I think that there's so much kind of going on globally at the moment. It's an exciting time, not only in the UK, but, further afield to look at kind of, the kind of new architecture that's emerging post-pandemic, responsible kind of architecture that's beginning to emerge, and just go out there and do it, go out there and practice it and be bold.
Definitely, it's time to explore, isn't it? Another question, this one from Evan. At the beginning of the talk, you criticised Norman Foster's mechanical systems for the Bloomberg building. What type of approach do you take?
I think I criticised the Bloomberg building's mechanical systems. I don't want to kind of completely curtail my career.
Well, commented on what type of approach do you take towards these systems within your own designs to maximise the self-sustainability of the building?
Yeah, in terms of operational use, we think a lot about the orientation of the buildings that we design. We think a lot about, the solar control, the glazing, about insulation, about making sure that the buildings are, one of the brilliant things about building in CLT is because of the compression of the material, you get very airtight buildings. So you can achieve great airtightness without really any additional additional materials. So Actually, I think that, in terms of operational carbon, I think that building regulations are pretty good, and they go a long way. And certainly if you start to apply many more systems on top of what is needed to achieve building regulations, you get to a point where you can really forego any of that kind of sophisticated machinery by opening a window, accidentally opening a door, or kind of like, or just put a jumper on, or take a jacket off, or kind of, let some breezes through your house, or kind of like, I think that actually we need to adapt some of our societal behavior as much as kind of relying on technology to kind of bail us out of a system that technology put us in the first place. So I think that, it's, like I said at the very beginning, really, it's about a simpler approach to architecture and construction.
Yeah, definitely. So is the main thing that you try to design passively in most of the buildings you do?
Yeah, that's an even better way of putting what I just said.
A bit quicker, yeah.
Yeah, a bit.
Got a question from Sebastian. Whilst all timber buildings reduce concrete use massively, the ground connection is still generally concrete. Do you see a comparable, more sustainable alternative for tall buildings?
No.
Oh, that was a quicker answer.
There you go. I don't, it's kind of like, people have talked to me about kind of ash piles, like Venice is built on these kind of ash piles, these timber piles. I don't think that those things, I don't see the viability of those things long term. I think there are different ways of doing foundations, with gabions, and I think that probably it's best to try and forego lots of basements and things like that, so reducing the amount of concrete we use. I can see that carbon taxation will begin to increasingly reduce the amount of concrete that we use as well. So no, as I said to you before, I think there's always, there probably will be a use for concrete. There will be a use, in my view, for concrete going forward. It's just about vastly reducing that reliance.
Yeah, definitely. A question from Niall. Sorry if this has been asked and answered, but how far can we go with the CLT construction, as I feel we've only scratched the surface?
I think you're right. I think he's right, for sure. But I've got two sort of opinions about that, really. One is that the reason why we started to build in timber was because of sustainability, because of a kind of impact of construction on the environment. And tall buildings aren't very sustainable in terms of their kind of, how much they cost to service, how much foundation is required, how efficient they are. You get a building of 50 stories plus, and it's almost 50% net to gross. You've got as many lifts and staircases in the building as you have got plan around the lifts and staircases. So those buildings get really inefficient. And on top of that, you have, transport systems are really difficult to kind of, to be able to supply those buildings with people and services and stuff like that. And also, I don't think they make great cities. I think that, the kind of overshadowing, cities for kind of young people and for old people, for the elderly, are not kind of like, I don't think they benefit from myriads of tall buildings. So the challenge of building taller, which I take Niall's question to be going to, is certainly out there, and I think is very exciting. But I also think that we need to be very mindful that the kind of, when you go back to the sketch, always go back to the sketch when you're trying to kind of like unravel a question, and the sketch has always been about sustainability. So I think, and the other thing that worries me as well is that, you can go on to Design or any of the glossy magazines, and you see these kind of beautiful kind of like elegant CGIs of these tall buildings, and they're all kind of colored in brown, and then there's a little arrow that says made of timber, but it's not true. It's not real. They wouldn't have brown on the outside anyway, because you wouldn't have wood on the outside. Do you know what I mean? So it's like, and there's a great kind of lot of clickbait around that sort of image, which I don't think does timber any good. And I don't think it really does architects any good. But it is this kind of notion that, you know, that it's become sort of fashionable. And that really worries me as well, because if it's fashionable now, then next year it will be something else, and it can't be something else, you know, because the problem is not one of style or aesthetics. The problem is more serious than that.
Yeah, definitely. Just going back to a project you mentioned earlier, the one you're developing in Norway, talking about the sustainability of this site, was that kind of key to like unlocking that design? And how do you design in what is kind of quite an acontextual site if you're starting on what is a lake and connecting to areas of town?
Yeah, I mean, it's about kind of it's similar with Bushy in a way, you know, because when we did Bushy Cemetery, it's just on a big green field, and I'd only ever designed anything in my career that was kind of in a city, you know, on a kind of tight red line plan, you know, where you kind of like where you build as much building as you can get on that plan as possible, and then you're faced with a field, and they say, well, you need a building on the field. Where do you want to put it? And you're sort of still there going, oh, where do you start with that kind of thing? And it's a similar kind of thing in Bergen, really. You know, here's a lake. We thought we might put some houses on it. What do you think? You know, and the first thing you think about is maybe we should build them at the edge of the lake and kind of like, but then you begin to think about the access and about the kind of connections between the town. You spend some time there. We realized that there was this kind of like this beautiful old city, this emerging new city, and a terrible connection between the two. And so actually making a physical connection between those two and using that, and rather than that physical connection being just this kind of empty bridge, that it would kind of like be populated, almost like a sort of ancient London Bridge, you know, that it would be populated, that it would be something that would encourage people to walk from one side of town to the other side of town, became a really kind of important generator of that design.
Yeah, no, that's really interesting. And how you're talking about retrofitting as well in your research. Is that something that will be ongoing always for the firm and your
yeah and for you guys as well? I think you know, I think that the majority of an architect's work going forward probably will be about using existing structures, you know, refurbishing, repurposing, adapting existing buildings. I mean, that's kind of fascinating opportunity, actually.
Mm-hmm.
You know, look at all those incredible kind of edifices that we have all over the world, these massive concrete structures that are becoming increasingly redundant. What are we going to do with them? You know, if we're all working from home in the future, you know, what are we going to do with these big towers?
It's definitely an interesting question to ask yourselves as architects. Another question, can you tell us a little bit more about the cleansing strategy for the lake you're realizing?
Yeah, the reason why I mentioned that was kind of like this notion of regenerative design. Mm-hmm. You know, the idea that you can, through design, you know, begin to actually regenerate some of the kind of context of that building, you know, or of the processes that go into that building, that you can actually not just reduce the impact, but actually improve the situation. And we learn at first, just kind of anecdotally, we were learning about in Bergen, they were telling us about oysters and the fact that when populations began to grow in Norway and in the UK, in the sort of 14th and 15th century, people began to eat loads of oysters. And within 200 years, we had eaten nearly all the oysters in the North Sea. And we'd taken an ecosystem that had developed over millions of years and decimated it. And what that meant is that what oysters did in that ecosystem was to filter water. So each oyster filters about 20 liters of water a day. So they can filter that water, clean that water out. And now we don't have those. We have this big, dirty kind of North Sea. And certainly in the lake in Bergen, we had a situation where I was going to say using oysters, but it's almost like working with the oysters. We're able to clean the lake out, to filter the lake out, so that actually you can kind of cleanse that lake. So the idea is that by providing a habitat for the oysters, that can help regenerate the lake itself. So that was that was the idea behind that. We'll see how that works.
When will that project be realised?
So we're just going through the very first stages of planning at the moment. It's one of those, where the developer came to us and I think they thought we were going to build something small on the shore. And we came back and we went, well, we've had a look, think about that. But actually, those 20 houses you were thinking about, we thought maybe 2,000 would be better. And so when we submitted it to the mayor's office in Bergen, I think that we took them a bit by surprise. So we're just letting the dust settle down a bit and people get used to the idea.
Yeah, it seems like a really interesting project. I think we call for any more questions for Andrew, but really heard any more. But thank you again for coming tonight, Andrew.
No, my pleasure.
Having you really insightful lecture and great things for the students and then also people in industry have come to take forward in their practice. Kind of following on the point that we made about retrofits leads on to the next lecture that we have at the same time next week by Ailey Henderson of Page and Park. They've been winning quite a lot of awards for their retrofit projects with Leeds Playhouse Theatre and with Edinburgh Printmakers. Two projects they're going to speak to us more about next week at the same time. Thank you all for attending today and hope to see you all again next week.